Any other questions? Today we're doing the qualitative analysis lab. And so we're back on schedule on the syllabus. Since we're back on schedule, you should come prepped for the lab. This is a multi-part lab, though. It's a very long experiment. And so we're just going to break it up into different lab periods. And what qualitative analysis is we're just trying to detect the presence of some analyte or species. And so what types of things are we going to look for? Well, we could look for lots of different things. In this particular lab, we're looking for cations and anions. And so there's going to be a finite list of things. And the list of things, we could have a whole bunch of different cations, but we're going to have 10 cations. Sodium might be present, ammonium. What else? Iron, 3. Aluminum, 3+. Chromium, 3+. That's 5. What else do we have? Okay, so what I'd like you to do is follow along with me with the lab manual. It's going to be qualitative analysis. So you'll see calcium 2+, magnesium. I heard somebody say nickel, zinc, and one more. Silver. So in qualitative analysis, what we have are chemical tests for these particular cations. And we'll be taking advantage of their physical and chemical properties in order to detect the presence of these specific. For the anions, we have some chemical tests for these too. The anions that we could have present are nitrate, chloride, sulfate, etc. All right, so we're going to be doing a whole bunch of chemical tests. And we have two major types of chemical tests. We have ones that are just for the individual ion. And so the individual test, this requires one sample of solution. These are all going to be aqueous. So one sample of solution in which we can test for that one ion. And so for individual tests, we'll have something like the sodium ion test. The sodium ion test, what that consists of is, well, sodium is actually easy to detect via flame. And so let's take a look here. We have our standard blue flame. This is a methane flame here. And for the sodium test, what we're going to do is we're going to introduce our sample into the flame by dipping a metal wire, into the sample and then just putting it in the flame. And what we should see is something like this here. Well, let me just put this on. Do you see that yellow? That's sodium. This is a paper clip, by the way. We're going to use, paper clips are going to get oxidized, so this paper clip's turning black. So we need a metal or some alloy that's really hard to oxidize. One metal that's really hard to oxidize is platinum. And so we'll end up using platinum or nichrome. Nichrome's an alloy. It's like a stainless steel type alloy. But if you see that yellow color in the flame, the yellow color is due to the presence of sodium. Okay, so the first thing we need to take a look at is, sodium is pretty ubiquitous because everything you touch, you leave behind a residue of sodium. And so you can see that this is pretty bright yellow here. And that means this is testing positive for sodium ion. And so the first thing is your wire is most likely going to test positive for sodium ion. And so we could try washing it. Try washing it off with DI water. But it's still going to be hard to wash off all the sodium. So I just wash that off. And do you see there's still color in there, in the flame? And so what we need to do is we need to do a combination of washing and then acid rinse and then burning. And ultimately you're just going to burn off the sodium off the metal here. And burning off the sodium can take a long time. Last semester somebody was standing here and after about 30 minutes they gave up. What they did was they went and got a clamp, like a 3-prong clamp, clamped their wire and then just left it over the burner. And they came back another hour later and it was finally clean, but it took an hour and a half of burning to get that wire clean. Well, hopefully this doesn't take that long. And so I'll just burn this off a little more. But what we should see is we should see this wire impart no color to the flame once it's clean. I shouldn't have used this one. Maybe it's getting close. Maybe you should come back in about an hour and a half. It should be good. All right, but what's going to happen is that the wire is going to burn clean. That is, there should be no color to the flame other than the blue color of this. Now the problem with sodium is this test is so sensitive. It just takes a tiny bit of sodium to cause a positive test for this. That tiny bit of sodium can come from fingerprints. So did you see that color there? Or can come from contamination. Like, let's take a look at this here. Okay. Well, it's still a little bit, but not that much. And then what do you think about tap water? Does tap water have sodium ion in it? Yeah? Probably? All right, let's test our tap water. So I'm going to hit this. And so I'll just get a little bit of tap water on the end of the wire and let's take a look. Here. Do you see that? Yeah, so tap water is testing positive for sodium ion. I mean, there's a pretty bright orange flame. How about DI water? DI water, should it have sodium ion on it? It shouldn't. Now, tap water, how long does it take to burn off? It seems to take a long time. So let me try to rinse this off with some DI water. Burn it off a little more. Still not clean. Still not clean. So what we do is keep trying to clean this. There's some certain tricks you can use. They're in the book's procedure. But eventually it's going to come out clean. And then we'll test our sample by just getting a drop or two of liquid on the surface of the wire and then seeing, does it give a bright yellow flame? And this one might be difficult to interpret because is that due to improper cleaning, or is that due to a positive test for sodium in DI water? There shouldn't be any sodium in DI water. All right, so that's the sodium test. Not all tests are going to be like that. So. But what we're going to do is we're going to analyze this test based on the observation and an equation for that. So the observation is, if I had some unknown aqueous solution, I'll just call it unknown AQ, and I put this in the flame, then I get a bright, what was that, bright yellow, orange flame? So we'll just say bright yellow flame. Now what's happening, or what's causing this observation is this, and we'll see it in the chemical equation. That must mean I have sodium ions present in solution, so sodium AQ. When I introduce this into the flame, what happens is this: the sodium ions become vaporized, and we form sodium ions in the gaseous state. Now, a flame is what we call plasma. A plasma, what happens is there's so much energy, because the temperature is so high, there's so much kinetic energy that there are violent collisions in the flame. Those violent collisions cause ionization to occur. And so we form, in a flame, ions and free electrons. And what happens is, well, in this case, we have gaseous ions. What happens is there are different parts of the flame. There's parts that are more reducing, and there are parts that are more oxidizing in the flame. And so the sodium ions can go into a more reducing part of the flame and be reduced to sodium, not the ion, but just sodium, the element, Na. And those sodium atoms can collide. When they collide, the electron in the sodium gets promoted to an excited state. So this represents sodium in an excited state. But it doesn't stay excited forever. Eventually it drops back down to the ground state. And in the process, energy is conserved. That energy goes into a photon here. This would be the yellow photon of sodium. And so this would be the observation equation. This is an individual test for sodium. We're also doing an individual test for ammonium, but before I talk about the ammonium test, this. Cleaning this wire is not easy. You know, cleaning this wire takes a lot of time. And we're not just doing the sodium test. We're doing one more flame test. The other flame test we're doing is calcium. And so you don't want to have to clean the wire twice. So what we're going to do is we're not going to do the sodium test yet. We're going to postpone the sodium test until calcium's ready. When calcium's ready to be tested, we'll test calcium first, because calcium is very difficult to detect. The reason it's so difficult to detect is because the flame is so weak, the flame color. The flame color is different than sodium. It's a brick red color. But it's so weak that if there's any sodium, the sodium will completely drown out the calcium, and you won't be able to see the calcium. And so we have to make sure that the wire is especially clean for calcium analysis, because it's going to give us a brick red flame, which doesn't last very long. Sodium persists, and it persists too much. It's difficult to clean, but calcium vaporizes almost immediately. It lasts for a couple of seconds, and then it's gone. You don't see it anymore. And so we're going to just clean the wire once, test it for calcium, and then in a separate sample, we'll test it for sodium. Not in the same sample, because we can't test for calcium when there's sodium present, because the sodium does something. It interferes with the calcium test. Interferences, that's a big problem in qualitative analysis. We got to make sure that other species aren't interfering in our analysis for a specific analyte. All right. Okay, another individual test would be the ammonium test. So what we do is, okay, we're done with the sodium test, then we go on to ammonium, we get a fresh sample of unknown. And the observation is going to be like this. Ammonia, one of the chemical properties of ammonia, it's a base. And so it should react with acids. But ammonium is not ammonia. Ammonium is an acid, NH4 plus. And ammonium should react, on the other hand, with bases. And so this is what we'll do. We're going to take our, actually the observation's not like that, sorry. Our observation's like this. What we're going to do is we're going to take our unknown, and the equation is, if our unknown contains ammonium, we're going to react it. Since ammonium's an acid, we'll react it with some base, like hydroxide, sodium hydroxide. And so if I react this with hydroxide, what does it form? Well, ammonium and hydroxide form ammonia and water. Well, ammonia is very polar, and ammonia can hydrogen bond with water, and so most of the ammonia is going to stay dissolved as AQ. And so this changes it, it changes it from acid to base. Now we have base. How do we detect the presence of base? We could use litmus paper to detect the presence of the base, but the problem is if we have excess hydroxide, that will also react with litmus paper. And so what I need to do is I need to separate the ammonia from any excess hydroxide that might be present here, because we're going to use excess. And so how can I separate ammonia from hydroxide? I could try a chemical separation. I could try to think of something that reacts with hydroxide but not ammonia, or something that reacts with ammonia but not hydroxide. I could do that, or I could try a physical separation. In this case, I'm going to do a physical separation, and that is if I heat it up. If I heat it up, then the hydroxide is going to stay in solution. However, the ammonia is going to be driven off as a gas. And so NH3 gas. Now I've separated the ammonia from the hydroxide. Now I can test for it individually. Now how do I test for this? So basically what we have here is we have a beaker. This beaker is going to contain some ammonium ion and other stuff, plus ... And then I just pour in some hydroxide, sodium hydroxide in here. Then I'm going to end up with ammonia rather than ammonium. But also have excess hydroxide present here. And then I'll heat it up. When I heat it up, water will evaporate, of course, but also the ammonia. The ammonia will be driven off as a gas. Now, ammonia is an interesting gas because ammonia is a gas that's also a base. And so what we can do is we can test gases if they're acidic or basic by doing something like this. So I'll get a watch glass here. If I want to test if the acid, if I have an acid, I would use blue litmus paper. If I want to test if I have a base, I'll use red litmus paper because bases should turn red litmus blue. So this is red litmus here. And so one way to get this red litmus to stick on here is to just use a little bit of water. I'll have to have a wash ball. But what we're going to do is we're just going to place a piece of red litmus paper on the base, or the bottom side of a watch glass. And so if I exhale on this, CO2 is what? Acidic or basic? Acidic. So CO2 being an acidic gas should leave red litmus red. But if I had blue litmus, do you know what CO2 would do to blue litmus? It would turn it red. But we aren't testing for CO2. If I was testing for CO2, that would work. But this is red. And so what I'm going to do is I'm just going to hold this, or actually I don't have to hold it. I'll just lay it on top of the beaker. If I lay it on top of the beaker, it'll provide somewhat of a seal.